Welcome, this is Coach Dorf. Let's look at a homework example from the Trig review that came from Appendix A. We want to find the exact values of cosine theta, sine theta, and tangent theta for a particular angle of theta. In this case, theta is 2 pi over 3. So the first thing that I would do here is I need to recall what are the values of sine and cosine in the first quadrant. Now, we don't know it for every value, but in the first quadrant, we have the following angles that we have values for that we know. We have 0, we have pi over 6, we have pi over 4, pi over 3, and pi over 2. So we can make a chart here, and we're going to look at the cosine of those angles. So what is the cosine of 0? Well, this is really a cool pattern. I think this really helps you remember the values if you can remember this pattern, the way this works. What it turns out to be is this is square root of 4 over 2, square root of 3 over 2, square root of 2 over 2, square root of 1 over 2, and square root of 0 over 2. See the pattern there? There's 2 on the bottom in every single case, and on the top we go square root of 4, square root of 3, square root of 2, square root of 1, square root of 0. It's a nice little pattern. Now we can simplify these. Square root of 4 is the same as 2, so 2 over 2 is 1. So this is more commonly known as 1. Square root of 3, it's not easy to simplify it, so we leave it as that. Square root of 2, same thing, we leave it as that. Square root of 1 is 1, so we write that as 1 over 2. And square root of 0 is 0, so we can just write that as 0. What about the sine values? Well, it's just the same thing, but in the opposite order. So we have square root of 0 over 2, which is 0, square root of 1 over 2, which is 1/2, square root of 2 over 2, square root of 3 over 2, and square root of 4 over 2, which is the same as 1. All right, having these values down, either memorizing them or remembering this chart, really makes things helpful in trying to do this. If I look at a circle, where are these angles in the first quadrant? So here's my circle. This angle here, well, so first I'll start with this one. That angle where we stay on the x-axis is theta equals 0. If I go up about here, this angle here is theta equals pi over 6. Maybe I should use different colors here. We'll do different colors. So that's theta equals pi over 6. Here, this is theta equals pi over 4. And another color, purple, here is theta equals pi over 3. And what color haven't I picked yet? We'll pick a darker green here. This one is going to be theta equals pi over 2. Now, technically 0 and pi over 2 are not in the first quadrant because they're on the boundary there, the border there. But those are the values that are important to remember when trying to solve the values of specific trig functions. So what the next thing to ask ourselves is, once we remember those, and the next question is, where is 2 pi over 3? In other words, is it in the first quadrant, second quadrant, third quadrant, fourth quadrant, or is it on some axes? Well, let's draw some circles here, right? And use purple. I like purple here. Here is 0, theta equals 0. Here is theta equals pi over 2. Here, and so that means we're going from this angle to there. Here, from here to here, this is theta equals pi. I go down here, so I'm going all the way around like this. This is theta equals 3 pi over 2. And if I go all the way around, it is theta equals 2 pi. All right. In this part here, this is known as the first quadrant. This red part is known as the second quadrant. This green part is the third quadrant. And no surprise that the last one is called the fourth quadrant. Now, what we're interested in knowing is what are the x and y values in terms of positive or negatives in these quadrants. Well, in the first quadrant, x is a positive value and y is a positive value. So when we say x, we mean we're along the x-axis, and we're along, for y, we're along the y value. So along the x-axis here in the first quadrant, x is always a positive value, and along the vertical axis, the y-axis, y is always a positive value. If I go to the second quadrant, it changes. Now x is less than 0 because I'm over here, and that's to the left of the origin, and there we have negative x values. But y is still positive because it's up here. In the third quadrant here, we will notice that x and y are both negative. And in the fourth quadrant, we have x is positive, but y is less than 0. Now, this will be important when we start figuring out the values, the exact cosine and sine values of these functions here. All right, so where is 2 pi over 3 in comparison to these different values? So we had theta equals 0, we had theta equals pi over 2, we had theta equals pi, theta equals 3 pi over 2, and theta equals 2 pi. Well, what do we get? 2 pi over 3 is going to be between these two here, 2 pi over 3. It's going to be between pi over 2 and pi, because this is really, I can think of 2 pi over 3 as 2/3 pi, and I can think of your pi over 2 as 1/2 pi, and I can think of pi as 1 pi. So 2/3 is between 1/2 and 1. That means that theta equals 2 pi over 3 is in which quadrant? Well, it's going to be in the second quadrant. That's this part right here. It's in there. And there we know, so x is going to be less than 0 and y is going to be greater than 0. So now what's next? The next thing we need to do is we're going to compare this 2 pi over 3 to one of the angles that we know in the first quadrant. So what angle in the first quadrant does 2 pi over 3 compare to? Well, this one's really easy because what I do is I look at the denominator here. And 2 pi over 3 has a 3 in the denominator. If I look at the angles in the first quadrant, so angles in the first quadrant are, including the boundaries, are 0, pi over 6, pi over 4, pi over 3, and pi over 2. Well, which one of these has a 3 in the denominator? So 2 pi over 3 has a 3, and pi over 3 has a 3. So this is what I'm going to compare it to. All right, so we're going to compare 2 pi over 3 with pi over 3, those angles there. All right, so now we're going to need to look at the corresponding x and y values. So let's look at the corresponding x and y values or I should say for theta equals pi over 3 and theta equals 2 pi over 3. All right, so let's draw some pictures here. Here's pi over 3, and here we're going to get 2 pi over 3. And what's important here is to notice that if I were to make a triangle here, a right triangle, this is my x value, and this is my x value here. The x value equals, in this case, the cosine of pi over 3. Maybe I should use a different color here. I'm going to call this my x value here. My x value here is going to be the cosine of 2 pi over 3. But what's the comparison between the purple x and the orange x, or yellow, gold? Maybe that's gold. Well, they have the same length, but one is in the positive direction and one is in the negative direction. Another way of thinking about that is for pi over 3, x is greater than 0, right? But for 2 pi over 3, that's in the second quadrant, and x is less than 0. Either way, whether you think of it as x is negative in the gold quadrant, or if you think of it that way, or you just think that it's in the second quadrant, so it's negative, it gives you the same result. So they have different signs, but they have the same value. They have the same length. So what that means then is that the cosine of 2 pi over 3, it has the same length as the cosine of pi over 3, but cosine of pi over 3 is positive, and cosine of 2 pi over 3 is negative. So to make them equal, I have to put a negative sign in front of the cosine of pi over 3. So now they're equal to each other. But what is the cosine of pi over 3? Well, going back to that chart that we made at the very beginning, the cosine of pi over 3 here is 1/2. So this is 1/2. So we get negative 1/2 for the cosine. So the cosine of 2 pi over 3 is negative 1/2. Now we do the same thing for the sine value. So what is the sine of 2 pi over 3? All right, if I again draw my axes here, draw my circles, all right, here, and then draw this in. Here's pi over 3, and here is 2 pi over 3. Here's my right triangle, and here's my right triangle. I'm now looking at the y values. So we're going to call purple here. This is the y value, and the y value equals the sine of pi over 3. And we know, sorry, that's a y. And the y, in this case, the purple one is in the first quadrant, so it's greater than 0. If I now look at here, I'm going to call this the y value. So that's going to be the y value of 2 pi over 3. So the y value here is the sine of 2 pi over 3. And in this case, the y is also positive. Both y values are positive. So what does that mean? That means if I'm going to look at the sine of 2 pi over 3, it has the same length. This green, dark green value for the sine of pi over 3, its length is the same length as the red line, which is the y value in the second quadrant, or the sine of 2 pi over 3. So they have the same length, and they both have the same sign. They're both positive. So the sine of 2 pi over 3 is going to be the same as the sine of pi over 3. And now if I go back again to my chart here, I'll do this in green here. If I look at the sine of sine of pi over 3, it's square root of 3 over 2. So I get square root of 3 over 2. So the sine of 2 pi over 3 equals square root of 3 over 2. That's how we figure that out. And last, what is the tangent of 2 pi over 3? Well, here it's important to remember that tangent is the sine over the cosine. So if I do the tangent of 2 pi over 3, it equals the sine of 2 pi over 3 over the cosine of 2 pi over 3. But we just figured out those values, right? The sine of 2 pi over 3 up here was square root of 3 over 2. And the cosine of 2 pi over 3, we just got up here. Here's the cosine. So I need to go all the way up to there to get that value. But that value was 1/2. So we have the tangent of 2 pi over 3 equals square root of 3 over 2 over 1/2. And so that's the same thing as square root of 2 divided by 1/2. And how do I divide fractions? I multiply by the reciprocal of the second one. So I flip 1/2, and that gives me 2 over 1. All right. And now I can cancel out the 2's. I could multiply the top and the tops together and the bottoms together, but I'm going to do something that's quicker. I'm going to cancel out a 2 on the top with a 2 on the bottom. And then when I multiply them, I get a square root of 3 on the top and a 1 on the bottom, and I just get square root of 3. So the tangent of 2 pi over 3 equals square root of 3. All right, hope that helps. Have a great day.